Hello there, this is Alana Tucky, and I've received a question about this problem in AFMA 31. This is 3.1 number 31. If you look up in the top right corner of the problem, you can see that. Where it comes in your particular homework exercises, of course, is anybody's guess. So I'm going to click View an Example, and I'll walk you through the example. So we have the number of landline and wireless calls placed to an information service is shown in the table for the right to the right for various years. Let L of t be the number of landline information calls and W of t be the number of wireless information calls, both in billions in the year that is t years since 2000. Use that information to complete parts A through C. So the first thing they want us to come up with is an equation for L and an equation for W. And if you read further, they want to let t be the year since 2000. Actually, they said it right here at the top. So let me type all that up real quickly. All right, so we want to find an equation for L of t and W of t. So I'm going to grab the calculator for a second. I'm going to go to Stat. At least I think I'm going to go to Stat. There we go. I'm going to go to Edit. And if you didn't have these cleared out, you'd have to go up and press Clear, Enter to clear them out, but mine are cleared out. Now, for the first column, I want to put in my t values, not my years, but my t values. But remember that t is years since 2000, so that makes this particularly easy. This is going to be 1, 2, 3, 4, 5. Simple as that. Then over here, I want to put in these numbers. Oops, except I typed that one wrong. There we go. And there we have it. So we have those in there. Now we want to be able to find the equations. So let me go to Stat, move to the right to Calculate, and I want number 4, which is linear regression. Now you can either move down with, like I just did with the arrows, till it's highlighted 4 and press Enter, or you can actually just press the number 4 from wherever you are. So I see number 4, so I press number 4. And it wants to know what I want for my x and my y. Well, I want L1, that's the t values, to be my x, and I want my y to be L2, which was the landlines. And then I'm just going to store this equation because I'm going to need it later for part B. So let me do this right now and get it over with. So I'm going to press Variables, V-A-R-S. I'm going to move the right to Y variables. I'm going to pick number 1 function, and I'll pick number 1. And then I'm going to move down to Calculate and press Enter. So it ran the equation for me, and it stored it for me in y equals. If I go to y equals, I can see it right there. Okay. All right, now I need to do the other variable set. So if you remember Stat Edit, you had L1 is your t values and L3 is your wireless. So I want to press Stat, move to the right to Calculate, pick number 4. But this time I want to tell it L3 for my Y list because L1 is still my t values, still my time. But L3 is where my numbers are. So I'm going to press second, 3. This button up here, second, and then 3. And it should say L3. And then I'm going to store the equation again because I need it for part B. So I press Variables, Y variables, Function. But I don't want to pick Y1 because I already have the first equation stored in Y1. So I'm going to pick Y2, which is number 2. And then we move down to Calculate and press Enter. And there's that one. Now if I go back to y equals, you can see that it took away my old equations that I had in here and put in the new ones. There's the landline right at the top, and there's the wireless down at the second one. Lovely. All right, so let me type those up somewhere in our worksheet here. 1 second. There we go, I have them typed in. Keep in mind that I have to switch the variables from x, which the calculator gives, to t because those are the variables for my particular problem. All right, now for part B, let's go back to the problem real quick. We did that. We came up with the equations. Oh, same equations as them. Wonderful. Now we want to use intersect on the graphing calculator to predict in which year the number of landline calls will equal the number of wireless calls. I'm going to guess that already happened in the past, but let's figure it out. Oops, not that picture. Sorry about that. All right, so if I press graph right now, it's set up for some old problem that I had with men and women speed skating times. And I can see there's some kind of X over there, but it's just not pretty. So what I want to do is I want to go to my window and I want to think about this. So X is time, T for us. And you can see that they're getting pretty close to each other right here. So I'm going to go to 0 to, well, I go to 5 in the table. How about I go to 15? That'll give it plenty of time to intersect. And if I'm going to go to 15, I might as well make it so that my my scale is 1, because that'll give me 15 tick marks. That's fine. Now 0 is fine for my y because that's the number of calls I'm going to make. And then for the number of, or excuse me, for the y max, I can see that I'm at 3.8 as a high value here. So how about 5 and make each tick mark worth 1? If it's not enough, we can go back and fix it later. All right, then I'll press graph. There's the landlines going down. There's the wireless going up. Perfect. So I'm going to hit second, calculate, pick number 5, intersect. And again, you can either go down and press enter, or you can just press 5. And this is beautiful. I'm right there. Enter, enter, enter. So that's my first curve, that's my second curve, and this is my guess. And it finds the answer for me. So I'm going to copy and paste that right into my worksheet. So find the intersection. All right. So to show your work, of course, you copy a picture down of what it looked like on your paper, right? So you make a picture just like this to show work. All right, what else do they want to know? Do they want to know what it means? Yeah, find the intersection and find when the number of calls will be the same. All right, so let's say that. So according to the model, the models, because there's two of them, the pink one and the blue one, the number of landline and wireless calls will be the same during 2007 at 3.127. This has to be like million phone calls. Let's go back here. Millions, yep, million phone calls. Okay. Now, the weird thing about this is this during 2007. So where did I get that from? Well, I did it because it said 7.727. So 2000 was my starter year plus 7.727 makes it 2000 7.7, which I would say is in 2007. But my math lab often likes you to round. And so if that's the case, you'd round it to 2008. So you could say by 2008, by 2008. So by 2008, they will be the same number. Okay. And I believe that's the one that my math lab actually wants in this particular instance. This author is particularly unclear a lot of the time about what he wants and what makes the most sense, whether you want to round it or not. So the people that make my math lab are kind of stuck having to do whatever he did. So in this case, he did round it to 2008. So they went to 2008. That's going to happen. It's sometimes best just to kind of look through the example and see which one they wanted. And we did. All right, so now in 2006, the average cost of a typical information call was $1.25 for landline calls and $1.50 for wireless calls. Estimate the total money collected from landline and wireless calls in that year. Okay, well, if we want to do that, we're going to need to know how many calls there were, first of all. So, let's see. Oh, million, I should say information phone calls. Right, so this is calling information. All right, estimate the money from information phone calls in 2006. All right, so we'll start with T. T is 2006. Take away 2000 as our starter year, so that's 6. So we're going to take 6 and we're going to substitute it into both equations. So I want to find L of 6 and W of 6. Let me find these two. So where there was 6, or where there was T, excuse me, I'm going to put in 6. So I want negative 0.1 times 6 plus 3.9. And while I'm on the subject, I want W of 6, which would be equal to 0.23 times 6 plus 1.35. Okay. So if I grab the calculator, make this go away. You can do this a couple ways. First, I'm going to quit, get out of here. Second, quit. I'm going to take negative 0.1 times 6 plus 3.9. I get 3.3. So this one's 3.3 million calls, right? And then this one would be negative, make sure you, positive 0.23 times 6, plus 1.35. And that makes, I really messed that up, 0.23, sorry about that, times 6, not 60.23. There we go, I knew it wasn't that different. So that's 2.73 million calls. All right, so now I have how many calls are being made. So this is how many. I still need to know the money from it. Okay, so that's my next calculation. So they were making $1.25 for landline calls, and then $1.60 or $1.50, excuse me, for cellular calls, wireless calls. All right, so let's see here. So the landline money is going to be 3.3 million times, they were $1.25 a call. $1.25 a call times 3.3 million. You can just do 3.3 and then you're just going to put the million at the end of it. So we'll say 1.25 times 3.3. That's $4.125 million. There we go. And now I need the money for the wireless. So that'll be right here. And that would be 2.73 times 1.50 because they were $1.50 per call. So 2.73 times $1.50. So 1.5 times 2.73 makes 4.905. Oh, 0.95, sorry, $0.95 million. And there we have our two results. So let's see if these values match what they actually said it was, and then we'll know if we did it right. Yep, 4.095, and oops, no, what? Oh, they want the total revenue. Oops, I didn't even notice that. Okay, so that means the total revenue is those two numbers added together. So let me write that up. All right, so let's say it's 4.125 plus 4.095, which would be 4.125 plus 4.095 gets us a total of 8.22. So $8.22 million. And there we go. And I believe that's what they actually wanted from the problem. Let's go back to it real quick and double check. So part C, it says estimate the total money collected from landlines. All right, so there we have it. It's 8.22, which means I don't want these to be in boxes because they're not the actual answers. They're the parts of the answers you need in order to come up with the total revenue that you were looking for. All right, so we're all done with that. I hope that was helpful for that problem. I'll see you back here for more tutorials.